Right, guys. Good evening, all. Good evening, everyone. Right. So, ఈరోజు నిన్న జరిగిన TSPSC Assistant Executive Engineer TSPSC Assistant Executive Engineer ఎగ్జామ్లో ఎలక్ట్రికల్ మెషిన్స్ నుంచి చాలా క్వశ్చన్స్ ఇచ్చాడు సార్. 4 ఎలక్ట్రికల్ మెషిన్స్ కలిపి చాలా క్వశ్చన్స్ వచ్చాయి. ఇప్పుడు ఈ క్వశ్చన్ పేపర్ ఎక్స్ప్లెనేషన్ లో జస్ట్ నేను ఎలక్ట్రికల్ మెషిన్స్ మాత్రమే ఎక్స్ప్లెయిన్ చేస్తున్నాను. ఇది జస్ట్ నాట్ ఓన్లీ ఫర్ దిస్ క్వశ్చన్ పేపర్ ఎక్స్ప్లెనేషన్ బట్ ఆల్సో ఫర్ ఇంకా ముందు మీరు ఏ ఎగ్జామ్ కి ప్రిపేర్ అయినా హౌ దే విల్ ఆస్క్ యూ క్వశ్చన్స్. ఎవరైతే ఇంకా నెక్స్ట్ కాంపిటేటివ్ ఎగ్జామ్స్ కి ప్రిపేర్ అవుతున్నారో ఫర్ దెమ్ దిస్ ఇస్ మోర్ యూస్ఫుల్. దిస్ ఎక్స్ప్లెనేషన్ we are going to explain clearly each and every question. Okay, who are preparing for further exams? Who are preparing for further exams? Good evening, Amma. Right? Clear everything? Right? So in this, first transformer తీసుకుందాం sir. Transformer easy గా ఉంటుంది కాబట్టి. అవును కదా sir? Easy గా ఉంటుంది కాబట్టి. Transformer lo first question, if PE and PH denotes the eddy current losses and hysteresis losses in a magnetic core operating with an alternating flux density waveform of frequency F, alternating flux density waveform with frequency F అన్నారు. సో మనకు తెలుసు PE అంటే ఎడ్డీ కరెంట్ లాసెస్, PH అంటే హిస్టెరిసిస్ లాసెస్. జనరల్ గా ఎడ్డీ కరెంట్ లాసెస్ ఫార్ములా మీకు ఐడియా ఉందా? ఎడ్డీ కరెంట్ లాస్ ఈక్వల్ టు సమ్ కాన్స్టెంట్ K into B maximum square into F square into T square, F square into T square. If V by F constant nothing but the B maximum constant and K already constant, thickness also constant, so eddy current loss is directly proportional to frequency square. But hysteresis losses formula enti sir ante hysteresis losses is equals to some constant Steinmetz constant neta into Steinmetz constant into B max whole power x. For silicon steel its value 1.6, B max whole power x into F into V, where V is the volume, V అనేది వాల్యూమ్ ఆఫ్ ద కోర్. ఇక్కడ జనరల్లీ ఒకసారి ట్రాన్స్ఫార్మర్ కానీ ఏదైనా మెషిన్ తయారు చేసిన తర్వాత వాల్యూమ్ ఇస్ కాన్స్టెంట్ as well as Steinmetz constant already a constant. If V by F constant, generally this is also constant, then WH directly proportional to frequency, or directly here W is directly proportional to frequency square, WH directly proportional to frequency. ఇది మనకు తెలిసిందే. So total loss is directly proportional to frequency is the wrong answer. WE proportional to F square, PE directly proportional to F square, PH directly proportional to F. ఇది 100% కరెక్ట్ ఆన్సర్. తర్వాత ఇంకా ఆప్షన్స్ ఇచ్చాడు, మనకు అవసరం లేదు. దిస్ ఈజ్ 100% కరెక్ట్ ఆన్సర్. రైట్, దిస్ ఈజ్ 100% కరెక్ట్ ఆన్సర్. రైట్, సో దిస్ ఈజ్ వెరీ సింపుల్ క్వశ్చన్. నెక్స్ట్ క్వశ్చన్ అడగాలనుకుంటే ఇక్కడ WE డైరెక్ట్లీ ప్రపోర్షనల్ టు F స్క్వేర్ T స్క్వేర్, దీన్ని బేస్ చేసుకొని ఇంకా క్వశ్చన్స్ కూడా అడగొచ్చు సార్ నెక్స్ట్ కమింగ్ ఎగ్జామ్స్ లో. బీ కేర్ఫుల్ అబౌట్ దిస్ ఈజీ క్వశ్చన్. నెక్స్ట్ దాని తర్వాత వాట్ ఈస్ నెక్స్ట్ క్వశ్చన్? See, this is also very easy question. Right, sir. Bachel's relay commonly used for the protection of. Bachel's relay దేన్ని ప్రొటెక్ట్ చేయడానికి యూజ్ చేస్తారు సార్? ట్రాన్స్ఫార్మర్ ని ప్రొటెక్ట్ చేయడానికి యూజ్ చేస్తారు. Bachel's relay connected in between main tank and conservator tank. Bachel's relay generally used in oil immersed transformers. But Bachel's relay is a gas activated relay. This is not oil activated relay. This is a gas activated relay. This is a gas activated relay. ఇది మనకు తెలుసు generally. So option 3 is the correct answer for this. Correct answer for this. Next, which type of transformer is used in AC welding? For example, resistance welding. In resistance welding, generally the required voltage is just 10 to 15 volts. Required voltage is 10 to 15 volts. For example, this is the primary which is connected to 230 volts and the secondary which is connected to the electrodes. For example, this is only 10 to 15 volts. Nothing but which transformer we required here? Ultimately, the step down transformer we required here. And especially the transformer is continuously variable reactor core transformer. Continuously variable reactor core transformer generally used here. Reactor core transformer generally used here. This is generally for AC welding. For DC welding, which generator is preferable? For DC welding we required which generator, sir? For DC welding we required differentially compound DC generator. For DC welding we require differential compound DC generator. Differential compound DC generator we required. Right? Next one. What is the next question? What is the next question? Let's see this. For parallel operation of two single phase transformers with same voltage ratio ఉంది and different KVA ratings ఉన్నాయి. అది ఆ parallel ఆపరేట్ అవుతున్నప్పుడు the load is shared by these transformers is proportional to their KVA rating. Load shared by their KVA rating అంటున్నాడు. అప్పుడు when the transformers have in this condition, generally the KVA rating directly proportional to per unit impedance. The load directly proportional to per unit impedance. If the per unit impedances are same, then the load KVA also same. Load KVA also same. Like that, when there is proportional to its KVA rating, nothing but equal per unit impedances should be there. Equal per unit impedances should be there. That is generally the thing. Okay, so the answer is equal per unit impedances on their respective ratings. This is a very simple question. Generally in single phase transformer, what are the conditions? The polarity should be same, voltage ratio should be same, X by R ratio should be same, as well as the KVA directly proportional to per unit impedance, or of course KVA inversely proportional to impedance. Okay, so you need to remember those things. Next one. The maximum efficiency of single phase transformer operating at unity power factor is found to be 90%. Under full load conditions. The efficiency at off load at the same power factor. అని క్వశ్చన్ అడిగారు సార్. ఈ క్వశ్చన్ మనం ఆల్రెడీ చేస్తుంటాము. ఈ క్వశ్చన్ ఏంటి సార్? ఎఫిషియన్సీ 90%. I don't know KVA by KVA plus iron losses plus copper losses. Maximum efficiency అన్నాడు కాబట్టి iron losses copper losses same ఉంటాయి కాబట్టి I am taking as 2W. In this condition, calculate the W. See here, 90 into KVA plus 180 into W cross multiplication is equals to 100 into KVA. అప్పుడు 180 into W is equals to 100 KVA minus 90 KVA అంటే 10 KVA 0 cancel. So W is equals to KVA by 18. Just remember this. W is equals to KVA by 18. ఇప్పుడు ఏమన్నాడు? The efficiency at off load with same unity power factor. Off load దగ్గర efficiency ఎంత అన్నాడు? అంటే half into KVA divided by half into KVA plus ఐరన్ లాసెస్ అంటే W కదా, W ఎంత సార్, kVA by 18 ప్లస్ దట్ ఈస్ ఐరన్ లాసెస్ ప్లస్ కాపర్ లాసెస్ ఆఫ్ లోడ్ దగ్గర ఎంత ఉంటాయి, ఫుల్ లోడ్ కాపర్ లాసెస్ by 4 అంటే దిస్ ఈస్ యాక్చువల్లీ ఫుల్ లోడ్ by 4, సో kVA by 4 into 18. If you solve this, you will get the answer directly. ఓకేనా, ఎంత వస్తుంది సార్, ఇక్కడ kVA by 2 ఉంది, ఇక్కడ kVA by 2 ఉంది, మరి డినామినేటర్ లో మొత్తము ఎంత వస్తుంది సార్, LCM 18 into 4 వస్తుంది, ఇక్కడ 36 into kVA ప్లస్ 4 into kVA ప్లస్ kVA ఇట్లా వస్తుంది, 36 4 41 kVA by 4 into 18, 2 ones are 2 twos are, అంటే ఇది ఒక 36 kVA cancel, so 36 by 41 if you calculate this 36 by 41 చేస్తే ఎంత వస్తుంది సార్ అంటే 87.8 వస్తుంది సార్, 87.8% వస్తుంది. This is the question. This is important. This type of questions they will ask you generally. Okay sir, next question see ఒకసారి దీన్ని చూడండి సార్, right, ఏమన్నారు సార్, which of the following statements are entirely true regarding eddy current losses లో ఏది కరెక్ట్, కింద ఇచ్చిన దాంట్లో ఫస్ట్ ఏమన్నాడు, eddy current losses can be minimized by using material which have low hysteresis coefficient low hysteresis coefficient ఉన్న మెటీరియల్ యూజ్ చేస్తే hysteresis లాసెస్ తగ్గుతాయి, eddy current losses కాదు, eddy current losses తగ్గవు సార్. Eddy current losses can be minimized by using material which have low hysteresis coefficient, ఇది కూడా wrong answer. Eddy current losses, the direction of eddy current losses can be found by Lenz law and eddy current losses proportional to square. Eddy current losses proportional to square correct. Eddy current losses can be minimized by laminating of core and eddy current losses proportional to the flux frequency. Eddy current losses proportional to the flux frequency. ఇక్కడ రెండు ఉన్నాయి సార్, ఈ రెండు ఇక్కడ డైరెక్షన్ ఆఫ్ eddy current losses can be found by Lenz law and eddy current losses directly proportional to square of the flux frequency. ఇక్కడ eddy current losses can be minimized by laminating core and eddy current is proportional to the flux frequency. ఇక్కడ eddy current losses directly proportional to the flux frequency square, but ఇక్కడ eddy current is proportional to అన్నాడు కాబట్టి so mostly option 4 is preferable. Examiner option 3 ఇచ్చినా సరే మనం ఏం చేయలేం సార్ ఈ క్వశ్చన్ కి. 3 ఇచ్చినా సరే మనం ఏం చేయలేం, బట్ ఆప్షన్ 4 ఈస్ ప్రిఫరబుల్. ఓకే, సో దిస్ ఇస్ ద నెక్స్ట్ 6th క్వశ్చన్. నెక్స్ట్ ఈ క్వశ్చన్ కి ఆన్సర్ చూడండి సార్. లెట్స్ సీ, ఇది అందరూ చేయవలసిన క్వశ్చన్ సార్, చాలా ఇంపార్టెంట్, రెగ్యులర్లీ ఆస్కింగ్ క్వశ్చన్. Yeah, good evening all. Good evening sir. చూడండి క్వశ్చన్. In a single phase transformers supplied from constant input voltage constant, the magnitude of load current kept constant. లోడ్ కూడా కాన్స్టెంట్ ఉంది సార్, లోడ్ కూడా కాన్స్టెంట్ ఉంది, లోడ్ ఏం పెంచట్లేదు తగ్గించట్లేదు. while the power factor is varied, లోడ్ కరెంట్ కాన్స్టెంట్ ఉంది కానీ పవర్ ఫ్యాక్టర్ వేరే అవుతుంది, లాగింగ్, లీడింగ్, యూనిటీ ఏదైనా చేంజ్ చేసుకోవచ్చు. అండర్ దిస్ కండిషన్, ఈ కండిషన్ లో గుర్తుపెట్టుకోండి, లోడ్ కాన్స్టెంట్ గా ఉన్నప్పుడు యూనిటీ పవర్ ఫ్యాక్టర్ దగ్గర మాక్సిమం ఎఫిషియన్సీ వస్తుంది. పవర్ ఫ్యాక్టర్ కాన్స్టెంట్ గా ఉన్నప్పుడు నియర్లీ ఫుల్ లోడ్ దగ్గర మాక్సిమం ఎఫిషియన్సీ వస్తుంది. లేదు, పవర్ ఫ్యాక్టర్ కాన్స్టెంట్ గా ఉన్నప్పుడు మాక్సిమం ఎఫిషియన్సీ ఎప్పుడు వస్తుందంటే when the variable losses is equals to constant losses. ఎప్పుడైతే వేరియబుల్ లాసెస్ ఇస్ ఈక్వల్స్ టు కాన్స్టెంట్ లాసెస్ అవుతుందో అప్పుడు మాక్సిమం ఎఫిషియన్సీ వస్తుంది, అప్పుడు మాక్సిమం ఎఫిషియన్సీ వస్తుంది. అది పవర్ ట్రాన్స్ఫార్మర్ అయితే నియర్లీ ఫుల్ లోడ్ దగ్గర మాక్సిమం ఎఫిషియన్సీ వస్తుంది. అది డిస్ట్రిబ్యూషన్ ట్రాన్స్ఫార్మర్ అయితే నియర్లీ ఆఫ్ లోడ్ దగ్గర మాక్సిమం ఎఫిషియన్సీ వస్తుంది. We can get maximum efficiency at nearly full load for power transformer and nearly off load for distribution transformer. So which is correct? The maximum efficiency occurs at unity power factor. Load constant ga unnappudu maximum efficiency occurs at nearly unity power factor. Yes, are you clear? Clear kanipistunda sir? Board okay na? Right sir. Next question. Which of the following is correct regarding the eddy current in the coil? మళ్ళీ ఎడ్డీ కరెంట్ లాసెస్ పైన ఇది మూడో క్వశ్చన్ సార్, ఇది థర్డ్ క్వశ్చన్. ఏమన్నాడు సార్? ఎడ్డీ కరెంట్స్ కన్వర్ట్స్ యూస్ఫుల్ ఎనర్జీ ఇంటూ హీట్ అండ్ వేస్ట్. అదే లాసెస్ అంటాం మనం, we can call it as losses. Eddy currents helps in generating electrical energy. Eddy current flow in straight lines like a wire and complete circuit path without the power loss. Power loss undada sir? There is a power loss, eddy current power loss. By making use of laminated core, eddy current losses increased. So which is correct answer sir? Ultimately option A is the correct answer. Next, which of the following is a characteristic of an ideal transformer? Characteristics. ఏది కరెక్ట్ సార్? ఐడియల్ ట్రాన్స్ఫార్మర్ క్యారెక్టరిస్టిక్స్ లో జీరో ఎనర్జీ, జీరో స్టోర్డ్ మ్యాగ్నెటిక్ ఎనర్జీ. ఆప్షన్ ఏ. జీరో కోర్ ఫ్లక్స్, లార్జ్ మ్యాగ్నెటైజింగ్ కరెంట్, infinite core reluctance should be minimum, zero core flux and large magnetizing currents. Actually ga magnetizing currents ekkuvagane undali and zero core flux. General ga core flux ento undali, but ee mooditలలో the preferable answer edi sir ante zero stored magnetic energy. Zero stored magnetic energy is the preferable answer among this. Right? Good evening everyone sir. Next one, 10th one. Which of the following is purpose of using harmonic restraint function in power transformer? General ga transformer lo switching transients లో అన్వాంటెడ్ ట్రిప్పింగ్ ని అవాయిడ్ చేయడానికి to differentiate in between fault current and magnetic inrush current. To differentiate in between magnetic inrush currents and fault current ని differentiate చేయడానికి ఒక restraining coil యూజ్ చేస్తాం. That is called second harmonic restraining coil. Why? Because the magnetic inrush currents are not a symmetrical waveforms in transient period. Of course, in steady state period it is a symmetrical to x-axis, but in transient period this is not symmetrical. That's why the richest harmonics are the second order harmonics. So in this case, second harmonic restraining coil is used to avoid unwanted tripping, to prevent the false tripping due to magnetic inrush current, to prevent the fault current due to magnetic inrush currents. Right? This is actually very important question, sir, for BTech and diploma level. Next, what is this question? In transformer, the load current is kept constant while the power factor is varied. Under this condition, zero voltage regulation. Why we can get the zero voltage regulation? Actually, the voltage regulation is maximum in between 0.1 to 0.2 lagging. In lagging voltage regulation, positive. At 0.1 to 0.2 lagging, the voltage regulation is maximum, that is per unit impedance. Then after at unity power factor, the voltage regulation is per unit resistance. In leading, in between 0.95 to 0.9 leading, we can get zero regulation. Then after enters into the negative. So simple ga at load power factor of leading we can get zero regulation. This is well known actually. Right? Very good. Next. Idi koncham pedda problem, sir. Numerical question. What they given? The 3-phase induction motor rated at 15 HP. Nothing but efficiency is equals to output by input. Input is equals to output by efficiency. Output given is 15 HP. 1 HP is equals to 746 watts divided by efficiency is the 85. ఇది క్యాలిక్యులేట్ చేయాలి సార్. ఇది క్యాలిక్యులేట్ చేస్తే వచ్చిన తర్వాత దిస్ ఇస్ ద యాక్టివ్ పవర్ P. మనము పవర్ ట్రయాంగిల్ వేసుకుంటే దిస్ ఇస్ ద యాక్టివ్ పవర్, దిస్ ఇస్ ద రియాక్టివ్ పవర్, దిస్ ఇస్ ద అపరెంట్ పవర్. నా దగ్గర యాక్టివ్ పవర్ ఉంది, ఇప్పుడు నాకు రియాక్టివ్ పవర్ కావాలి. ఫ్రమ్ దిస్ tan phi, tan అంటే ఆపోజిట్ యాంగిల్ బై opposite side by adjacent side. From this Q is equals to P tan phi. P is this one, 15 into 746 by 0.85 into tan phi. What is phi actually? They given 0.9 lagging. From this, phi is equals to cos inverse of 0.9. అప్పుడు ఇక్కడ tan phi, tan of cos inverse of 0.9. ఇది డిస్కస్ చేస్తే, ఇది సాల్వ్ చేస్తే, how much you will get? Option B you will get. This is one of the toughest problem in the question paper. Easy, but calculator not allowed, right? That's why toughest. Next, coming to next question. This is induction machine first question. Transformer questions completed almost 11. And then after induction machine first question. Now the second question in induction machine. What is the status of machine flux for the range of frequency above rated frequency? In this case of a speed regulated V/F controlled induction motor. Speed regulated. Actually, Bmax is directly proportional to V/F. where B is equals to flux into area. B is equals to flux density, right? Flux density. B is equals to flux density, flux per area. B is equals to flux density. Of course, the B is directly proportional to flux. ఇప్పుడు ఏమన్నారు సార్? above rated frequency అప్పుడు ఫ్లక్స్ ఏమవుతుంది సార్? ఫ్లక్స్ డెన్సిటీ రెడ్యూసెస్. of course ఇక్కడ V by F maintaining constant, flux density maintaining constant, magnetizing current constant అని మెన్షన్ చేయలేదు కాబట్టి డోంట్ గో ఫర్ వోల్టేజ్. ఫ్రీక్వెన్సీ పెరిగితే ఫ్లక్స్ డెన్సిటీ రెడ్యూస్ అవుతుంది. అప్పుడు ఏమవుతుంది సార్? ఆన్సర్ మెషిన్ ఫ్లక్స్ డిక్రీజెస్ ఫ్రమ్ ద రేటెడ్ ఫ్లక్స్. అండ్ జనరల్ గా సార్ ఇఫ్ V by F లో ఇఫ్ ఫ్రీక్వెన్సీ రెడ్యూస్ చేస్తే ఫ్లక్స్ డెన్సిటీ ఇంక్రీజ్ అవుతుంది of course. But in V by F control, we can reduce the voltage also, no problem. But in this case, if you increase the voltage, it leads to damage of the insulation. That's why ikkada voltage ni increase cheyoddu sir. So which is correct answer? The machine flux reduces is the correct answer. Machine flux reduces is the correct answer. Right? Next one. What is this question? A constant V by F controlled induction motor fed from a variable voltage, variable frequency, three-phase voltage source inverter. Variable voltage, variable frequency, voltage source inverter. Use just now. The motor is operated within the base speed. Which of the following is true in torque speed characteristics of this motor? Which of the following is true with respect to frequency? They asked the starting torque and the maximum torque. First of all, maximum torque formula kV square by 2x2. Here k nothing but 3 by omega. Omega nothing but 2 pi ns by 60. ns nothing but 120 f by p. So k nothing but 1 by f. Here v square is there and k nothing but f, and in the reactance also 1 f is there. So v by f constant. So maximum torque is constant. The maximum torque is constant, unchanged. What about starting torque? Actually, the starting torque formula is different, sir. kV square s into R2 by R2 square plus s square x2 square. Actually, this is the torque formula. But at the time of starting, s is equals to 1. When s is equals to 1, actually compared to R2 square, x2 square is very larger. That's why the approximated starting torque formula kV square into R2 by x2 square. Here v square x square constant, because in the x 1 f is there. F square v square by f square constant, and k is there. So the starting torque inversely proportional to torque. When the frequency increases, the starting torque will decrease. So now in the second and third, starting torque decreases with decreasing in frequency. Starting torque increases with decreasing in frequency. Starting torque increases with decreasing in frequency. This is the analysis actually. Okay, this is the analysis, sir, actually. Right? So this is the questions. And this is very important for B.Tech level. In every question paper, one question will be there from variable voltage, variable frequency control, speed control. Right? Next question. What is the next question? See this question. The stator of a 3-phase 4-pole squirrel cage induction motor. 4-pole. That is a 4-pole machine which rotating at 1450 rpm at 50 edges. Actually, for 50 edges, synchronous speed is Synchronous speed is 1500 rpm, but it is rotating at 1450 because induction motor. Is rewounded to 6 pole. 6 pole వచ్చే విధంగా rewound చేశాడు. Rewounded to 6 pole without any changing in the rotor. Actually, this is a squirrel cage induction rotor, sir. If it is a slip ring induction rotor, మనం స్టేటర్ లో వైండింగ్ చేంజ్ చేస్తే 100% we need to change the winding of the rotor, otherwise the torque 0. But this is a squirrel cage. In the rotor we have a only copper bus. There is no winding to change. మనం స్టేటర్ లో చేంజ్ చేస్తే automatically due to magnetic replica the poles are will be takes place in the rotor itself. That is the advantage of squirrel cage induction machine. So ఇప్పుడు రోటర్ లో చేంజ్ చేయాల్సిన పని లేదు. ఇప్పుడు రోటర్ లో 6 పోల్ చేశాడు అంటే సింక్రోనస్ స్పీడ్ ఏమవుతుంది? 1000 rpm. Synchronous speed 1000 rpm. If synchronous speed 1000 rpm, the rotor speed should be less than 1000 rpm. So runs at same speed, wrong answer. Fail to develop torque. Of course, this is the correct answer for slip ring induction machine, but not squirrel cage induction machine. Operate with slightly below the 1000 rpm at 50 edges is the correct answer. This is correct answer. And operate with speed slightly above the 1800 is 100% wrong answer. 100% wrong answer. This is actually the answer. Very important questions are this is also. Next one. What is the way of importing braking action of 3-phase induction motor in plugging scheme? In plugging, generally plugging is also called reverse current braking. That is, if this is the phase sequence of my motor RYB, plugging nothing but we need to change the phase sequence. For example, if R is same, no problem. But the Y and B should be interchanged. That is RBY, which is the negative sequence, like that. Then it is called plugging. See, by increasing the stator voltage magnitude, by decreasing the synchronous speed, by decreasing the stator voltage magnitude, by reversal of phase sequence of the stator, is the correct answer. So this is the answer for this question. Next, 6th question in induction motor. In a slip power recovery scheme of 3-phase induction motor drives, what is the operating speed with respect to synchronous speed? If the power is injected into the rotor circuit. Here, for example, if the full load torque is constant, full load torque is equals to KER square into S by R2 or R2 square. Here I am not changing the resistance and K value. I am injecting EMF into the rotor. For example, this is my actual rotor EMF. Now I am injecting another EMF into the rotor. Finally, the resultant EMF value increases. This is rotor EMF, this is resultant EMF. When the resultant EMF value increases, the slip should be decreased. When the slip decreases, then the speed should be increased. That is called super synchronous speed. The speed increase. Motor speed equal to synchronous speed. Motor speed above the synchronous speed. Motor speed above the synchronous speed is the correct answer. Okay, motor speed above the synchronous speed is the correct answer. That's good. Very good, Balraju. Next, 7th one. At low values of operating slip, the torque developed in the induction motor. Low values of slip. Generally, induction motor torque slip speed characteristics are like this. Here NR is equals to 0. Here NR is equals to NS. Here S is equals to 1. Here S is equals to 0. What they asked? The low values of operating slip. This is not, sir. This is the low values of operating slip. At low values of operating slip, the torque characteristics are linear. Linear, nothing but directly proportional. Otherwise, from here to here, actually the slip is decreasing in manner. Of course, the torque also decreasing in manner. Both are decreasing. That's why the torque directly proportional to slip. The torque directly proportional to slip. The torque directly linearly proportional to slip. The torque linearly proportional to slip. Okay, that's good. That's good. Next, eighth question. In rotor resistance control of an induction motor, which of the following is true with increase in rotor resistance? Increase in rotor resistance. Actually, the rotor resistance, this is at normal rotor resistance. If rotor resistance decreases, the starting torque decreases. If rotor resistance increases, the starting torque increases. Generally, the starting torque directly proportional to rotor resistance. And slip at maximum torque is equals to rotor resistance by rotor reactance. The slip at maximum torque also directly proportional to rotor resistance. If you know these points, మనం ఈజీగా ఆన్సర్ చేయొచ్చు. What is the answer? Maximum torque remains unchanged, okay? Starting torque increases and slip at which maximum torque occurs increases. That is the answer. When the rotor resistance increases, starting torque increases. When the rotor resistance increases, slip at maximum torque increases, but the maximum torque is constant. Next option, maximum torque remains unchanged. Starting torque decreases and slip at which maximum torque increases. ఇక్కడ decreases అని ఇచ్చాడు, that is wrong answer. ఇక్కడ maximum torque increases is a 100% wrong answer. Is a 100% wrong answer. Right? So which is correct answer? First one is the correct answer. First one is the correct answer. Okay. Okay. Next one. Next one, ninth one. Next one, ninth one. What is the answer for this question? What is the condition to achieve regenerative braking? అది ఎక్కడైనా సరే regenerative braking అప్లై చేయాలి అంటే the motor will give the supply fed back to the supply. ఇది పవర్ ని జనరేట్ చేసి సప్లై కి ఇవ్వాలి. ఒక 60 to 70% of power fed back to the supply. When it is possible, when the machine acts as a generator, when the motor acts as a generator, when the motor acts as a generator, when the rotor speed greater than synchronous speed, then the motor acts as a generator and it will give supply to the reverse, fed back to the supply. So rotor speed ekku undali synchronous speed kanna. Synchronous speed increased. Synchronous speed em increase avadu sir. Synchronous speed should be little lower than the rotor speed. Synchronous speed should be little lower than the synchronous speed. Synchronous speed should be little higher. Wrong answer. Synchronous speed double, not right. So this is the correct answer. Yeah, ninth one is the second one is the correct answer. Next, what is the 10th one? What is the 10th one? 10th one. Reducing the speed in a three-phase induction motor by using stator voltage control. By using stator voltage control, I am reducing the speed. Generally, the slip inversely proportional to V square if V by F not constant. The slip inversely proportional to voltage with V by F constant. ఇక్కడ V by F కాన్స్టెంట్ అని మెన్షన్ చేయలేదు కాబట్టి ఇఫ్ స్పీడ్ ని ఏం చేస్తున్నాడు, రెడ్యూస్ చేస్తున్నాడు. ఇఫ్ వోల్టేజ్ రెడ్యూస్ అవుతే స్లిప్ ఇంక్రీజ్ అవుతుంది, స్లిప్ ఇంక్రీజ్ అవుతే ది స్పీడ్ రెడ్యూస్ అవుతుంది. దానివల్ల రెడ్యూస్డ్ ఎఫిషియన్సీ, ఇంక్రీజ్డ్ పీక్ టార్క్ క్యాపబిలిటీ, రిడక్షన్స్ ఇన్ స్లిప్ and higher area flux. So which is correct answer sir అంటే జనరల్ గా వోల్టేజ్ రెడ్యూస్ అవుతుంది. ఫుల్ లోడ్ టార్క్ షుడ్ బి కాన్స్టెంట్ సార్. ఇక్కడ ఫుల్ లోడ్ టార్క్ కాన్స్టెంట్ ఉండాలి. అదే సార్ టార్క్ కాన్స్టెంట్ ఉండాలి, మరి వోల్టేజ్ రెడ్యూస్ అవుతుంది అంటే ఇట్ విల్ డ్రా ద మోర్ కరెంట్. ఇట్ విల్ డ్రా ద మోర్ కరెంట్ డ్రా చేస్తే మోర్ లాసెస్ విల్ బి టేక్స్ ప్లేస్ and efficiency అనేది reduce అవుతుంది. So this is the correct answer. Completely analytical question. Completely analytical question. Yeah, very good, very good. Good answer. Next, which is correct answer here? Which is correct answer here? Three-phase induction motor with 6 pole, rotating at 1200 rpm. 1200 rpm దగ్గర rotate అవుతుంది. The speed of the rotation in electrical and mechanical. Electrical and mechanical. What is the mechanical angle? Omega is equals to 2 pi n by 60. N is the 1200. 2 pi n by 60. 61s are 62s are. So 40 pi is the electrical. Sorry, mechanical. 45 is the mechanical speed. What is the electrical speed? Simply, omega electrical is equals to P by 2 times of omega mechanical. P is the 6. 6 by 2 is the 3. 3 times of 4 pi. 3 times of 4 pi is the 120 pi. First electrical, tarvata mechanical. First electrical 120, next mechanical. Electrical and mechanical. Electrical and mechanical. Electrical and mechanical. Right? Very good, very good. Nice answer. So this is the answer. Next, ఇక్కడ ఇది కొంచెం different questions are actually confused అయ్యే question. Which of the following load offers characteristics close to constant load torque? Constant load torque ఇచ్చిన వాటిలో the best preferable answer low speed hoisting machines. In low speed hoisting machines, actually the torque is constant comparatively. Compared to remaining, this is the best preferable answer. Okay, this is 12th one. In induction machine, this many questions sir, inni questions vachai. An electrical machine wherein the self inductances of both stator and rotor windings are independent of rotor position. Generally, the reluctance torque is depends on the rotor position. The rotor position, but what he said, both stator and rotor windings are independent of rotor position, then there is no reluctance torque. Okay, the rotor and stator generally the reluctance torque directly proportional to sine 2 delta. When delta is 45 degrees, then the torque is maximum. It depends on the rotor and stator positions. If this is not independent, then rotor reluctance torque is 0. It doesn't produce the reluctance torque. Next one. Ikkada em question adigadu sir. What is this question? The speed of an induction motor is increased by increasing the frequency 20%. If the magnetizing current of the machine remains same, magnetizing current same, nothing but the flux density same. Flux density same, nothing but the V by F constant. Here frequency increased by 20%. Then in order to maintain constant V by F, the voltage also should be increased by 20%. The voltage also should be increased by 20%, then only both will be same. So supply voltage must increased by 20%. Supply voltage must increased by 20%. That is the answer. Right? Very good. Option 3 is the correct answer, sir. Decrease kaadu, increase. Next, the last question in induction machine. Enti sir adi? A motor load combination operating in motoring mode, first quadrant, has the following speed torque characteristics. It is sir. When T motor is a motor torque in Newton meters and N is the speed in RPM. What is the steady state speed of the synchronous machine or steady state speed of the system? Steady state speed ante ivi rendu equal avval sir. Both the torque should be equal. The motor torque and load torque. Nothing but 0.1 into N minus 10 is equals to 0.25 into N minus 75. Equate cheyandi sir. ఇక్కడ 0.1 ఉంది కాబట్టి దీన్ని ఇటు పంపించేస్తే 75 minus 10 65 is equals to 0.15 n. 0.15 n. N is equals to 6500 by 15. 6500 by 15. S 15 ones are 15 fours are. 15 fours are. 60. Again 50 is there. 3s are. 15 3s are 45. 50 is there. 45. 50 is there. 50 is there. So what is the speed? 433.3333 rpm. 433.3333 rpm. Very good. So this is the answer for 15th question. Next, synchronous machine. Coming to synchronous machine. Synchronous machine ఏమని అడిగారు సార్? Which of the following machine is most suitable for installation as a generator in coal-fired thermal power plant? In general గా hydroelectric power plant లో salient pole alternator and in thermal and nuclear power plants లో cylindrical alternators are more preferable. In hydroelectric power plant we are using salient pole, that's why this is hydro alternator and this is turbo alternator. This is turbo alternator. Very well. Generally we know cylindrical rotor. Yes? Yeah, Joshna? Good evening, Amma. Yes? This is the first one. What about the second one? Can you tell me the answer? Which of the following is the reason behind the inability of an ideal synchronous motor to develop starting torque? Which is the inability? Generally గా ఒక synchronous motor తీసుకుంటే, for example 90% of synchronous motors are salient pole motors. When three-phase AC supply given to the machine, ultimately it will produce the rotating magnetic field which rotates in clockwise direction with some speed is called synchronous speed. Then after మనం rotor కి supply ఇచ్చిన వెంటనే of course it will produce the magnetic field, but due to inertia it doesn't catches the fast reversal of stator magnetic field. Here the relative motion is maximum, that's why it doesn't catching. Relative motion is maximum, that's why it doesn't catching. The relative motion between these two is maximum, that's why it is not catching. The relative velocity between stator and rotor MMF is large. The stator MMF and rotor MMF relative motion is large, that's why the rotor doesn't catches the fast reversal of stator magnetic field, that's why it not getting start. That's why here the starting torque is equals to 0. This is the correct answer. Right? Very good. AP లో ఇంకా కొంచెం టైం పడుతుంది సార్. Still they are under process. ఇంకా మనకున్న ఇన్ఫర్మేషన్ ప్రకారం ఇంకా we are అంటే ఫైనలైజ్ చేస్తున్నాము అంటున్నారు సార్. ఇంకా క్లారిటీ లేదు. If any clarities are there, surely I will come with you. Right? Next, synchronous generator rated at 11 kV 500 MVA. Appudu per unit impedance given as 0.2 per unit on its own base value. Then its impedance referred to 22 kV. Actually ఇది ఎలా చేస్తాం సార్ అంటే, if మీరు మర్చిపోయినా సరే, మీరు ఈక్వేషన్ మర్చిపోయినా సరే, ఫర్ ఎగ్జాంపుల్ x per unit nu is equals to, generally what is the formula for x per unit? X per unit is equals to kV square by kVA, voltage by power rating. This is the new value, divided by x per unit old. X per unit old is equals to same kVA old whole square by kVA old, like this. Based on this we can calculate. If you want x per unit new, what is the value sir? X reactance. ఒకసారి చూడండి generally I want reactance nothing but voltage by current, that is called impedance. that is called reactance. If you multiply it with voltage again, numerator and denominator, then x is equals to V square by kVA. X is equals to V square by kVA. X is equal to V square by kVA. That is the reactors or per unit reactance, per unit impedance or per unit reactance. Per unit impedance or per unit reactance. From that we can calculate x per unit nu is equals to 0.2 into what is the value, sir, from this? X per unit nu by x per unit volt is equals to x per unit nu by x per unit volt is equals to this nu voltage square by volt voltage square into volt by nu. What is the value? The new value 22 into 22 by 11 into 11 into 11 into 11 into what is the value, sir? Volt 50 by 150. 1s 3s are, what is the value? 1s 3s are by 4, 0.2 into 4 by 3, actually not 3 by 4, 4 by 3. Here 4 by 3 is there, right? 4 by 3 or 3 by 4. Actually it should be a 3 by 4. 3 by 4. Then its value 0.053 is a 0.15. Okay, Amma. So this is the answer actually. So what will be the answer? Once see here. This is still it. So let's see here. X per unit nu is equals to 0.2 into 11 into 11 by 22 into 22 into 150 by 50. That is 0.2 into 3 by 4, 0.6 by 4, 0.6 by 4 or 6 by 40, whatever, then the answer is 0.15 per unit. 0.15 per unit. This is the answer for third one in synchronous machine. Next, fourth one. Generally in synchronous machine we have a different types of windings, like a full pitch winding, short pitch winding, concentrated winding, distributed winding. By using short pitch winding we can eliminate the harmonics. By using distributed winding we can eliminate the harmonics. This is lower order harmonics, this is higher order harmonics actually. Right? So see here, short pitching the winding results in reduced fundamental EMF compared to full pitch. Ante kada sir? Short pitch చేస్తున్నామంటే నెంబర్ ఆఫ్ స్లాట్స్ రెడ్యూస్ అవుతాయి కాబట్టి నెంబర్ ఆఫ్ స్లాట్స్ రెడ్యూస్ అవుతే అప్పుడు ఆటోమేటికల్ గా EMF కూడా రెడ్యూస్ అవుతుంది. ఓకే, నెక్స్ట్ వన్, షార్ట్ పిచింగ్ ఇంక్రీజ్ ద హార్మోనిక్ వోల్టేజ్. ఇంక్రీజ్ కాదు సార్, రెడ్యూస్ అవుతుంది హార్మోనిక్ వోల్టేజ్. Next one, short pitch coils have smaller length at overhanging. Yes sir, smaller length ఉంటుంది at overhanging because of short pitching. Okay, so like that, which is correct answer, sir? A and C correct answer. A and C correct answer. A and C correct answer, Joshna. A and C. A and C. For example, like this. For example, number of slots are there. The slots per pole we need to take. For example, slots per pole. For example, in one pole I have a 6 slots. For example, 1, 2, 3, 4, 5, 6. Now, for example, 2 slots are short pitched. Then, at overhanging, the what is that, coil smaller length. The coil having smaller length. If it is a 6, that is the coil having long length at the overhang portion, but when it is short pitched, the coil having less length. See here, compared to this one, here the length is small, right, at overhanging. That's why the A and C is the correct answer for this. A and C is the correct answer for this. Next, Okay, very good. Very good. Next, consider the following statements about the operation of synchronous machine. About the operation of synchronous machine. The armature reaction, generally in generator, this is the main field flux and this is the EMF. And in motor, for easy understanding, this is the EMF and this is the main field flux. Now, the armature reaction in the generating mode adds the flux when the supply is leading current. Leading nothing but for example pure leading. For example, pure leading nothing but the current is 90 degrees leading to the EMF. This is my armature flux, which is in adding. That is correct only. Next, the armature reaction opposes the field flux for a motor that draw the leading power factor. Leading nothing but again the current is here, armature flux is here, which is in opposite direction. This is also correct answer. Next one, armature reaction in motoring mode always opposes the field excitation. Always is the wrong answer. Why always? Only in leading it will oppose, in lagging it will add. So this is the wrong answer. So A and B. A and B is the correct answer. A and B is the correct answer. Very good, Paramesh. Very good. Right? Next one. Next one. This is very important question, sir, generally. So see here, two alternators are operating. One is the 200 megawatts, other one is the 400 megawatts. And they given to supply the load of 300 megawatts. The personal rating of the alternators they given, but the load is only 300 megawatts. If the governance of both the machines are set to be dropped at 4%, both the alternators are set to be at 4%. Set to be at 4%, for example. This is 4% regulation. This is also 4% regulation. It will share 200 watts at rated value. It will share 400, but this combinedly 600 megawatts. But what is the load I want? Only 300 megawatts I want. This is P1, this is P2. I don't know P1 plus P2, but I don't know P1, P2 individually, but I know the P1 plus P2 is equals to 300 megawatts. 300 megawatts. So what is P1, what is P2? What is P1, what is P2? 150, 150, 300, 50, 250, 300, 200, 100, 300, 100, 200, 300. All options are 300. Then how, sir? This is equal triangle method, same triangle, similar triangle method. For example, for 4% of regulation, it will share 200. Then for P1, it will share, or then X% it will share P1. For example, this is the X%. This is the X%. From this P1 is equals to, from this P1 is equals to 50X. And here for 4% it will share 400. For X it is share P2. That is X is equals to 100. That is P2 is equals to 100X. P1 is equals to 50X, P2 is equals to 100X. P1 is equals to 50X, P1 is equals to 50X, and P2 is equals to 100X. Then combine these two. Then combine these two. 150X is equals to 300. 150X is equals to 300. Then X is equals to 2. Then X is equals to 2. If X is equals to 2, P1 is the 50 into 2 and P2 is the 100 into 2. P2 is the 100 into 2. So the answer is option D for 6th question. Option D for 6th question. And this is also a previous question actually. What is the answer for this question? In an alternator, field current given 20 amperes result in armature current of 400 amperes when the terminals are short circuited. Nothing but ISC given 400. Next, the same field current also creates the terminal voltage of 2000 volts at open circuited. EOC given 2000. Then what is ZSC? ZSC is equal to EOC by ISC, 2000 by 400. 2000 by 400 is equals to 5 is the impedance. 5 is the impedance. Right, sir? Now what they asked, what would be the magnitude of the internal voltage drop within the machine at load current of 200 amperes? Load current of 200 amperes. Load current they given, then voltage drop is equals to I into Z. I is the 200, Z is the 5. I into Z, which is equals to 1000 watts. Which is equals to 1000 watts. Right, sir? Right, sir? This is generally the easy question. And next they given in salient pole synchronous generator with XD and XQ denoting the reactance in D axis and Q axis. What is likely to be the relation between them? Generally, in salient pole machine, in D axis, air gap length is less. In D axis, air gap length is lesser than the Q axis. Then the armature reaction more in the D axis. Then the reactance also more in the D axis. In the D axis, the reactance is more because of more armature reaction, because of more flux involvement. So, which is correct answer? In D axis, the reactance is more than the Q axis. In D axis, the reactance more than the Q axis. Which is correct answer? XD is greater than XQ. That's good. Next question. In grid controlled synchronous generator working at unity power factor, increasing the field excitation, that is over-excited condition. In over-excited condition, V by Xs into E cos delta minus V. In over-excited condition, E cos delta greater than V. That's why Q is positive. When Q is positive, it will deliver the reactive power. That is increasing the operating frequency. No, the frequency depends on the prime mover, not excitation. Increasing only the reactive power, yes, that is correct answer. Increasing only the active power, that depends on the prime mover, not excitation. Increasing both active power and reactive power to the grid is the wrong answer. This is also wrong answer. Only it will increase the reactive power. Yes, this is actually the correct answer. Joshna, which is correct answer? Now? Right? This is the correct answer. Next. These are the synchronous machines. Now the DC machines. Now the last one, DC machines. Coming to DC machine, the first question, 200 volts, 1200 RPM, 100 ampere DC separately excited motor, armature resistance given. Braked by plugging, nothing but what is the braking current? IAB is equals to V plus EB by RA plus RB. V they given as 200 plus EB. EB is equal to V minus IA. IA is the 100, RA is the 0.1, 200 minus 10, 195. RA 0.1 plus RB, that is equals to IAB. IAB given as armature current limited to twice the actual current, nothing but 200. That is 390 by 200 is equals to 0.1 plus RB. That is 39 by 20. RB is equals to 39 by 20 minus 1 by 10, because minus 0.1. That is 20 is the denominator. This is 39 minus 20. That is 19 by 20. What is 19 by 20? 19 by 20. That is 2 ones are 2, what is the value? 2 ones are 2 nines are right. 18.5, that is again 0.95. Is it 0.95? Is it? Any mistake? Is there any mistake? Is there any mistake here? Let's see here. That is 39 by 20. 39 by 20 means how much this is? 39 by 20 means 2 ones are 2 nines are 18.5 divided by 10. That is equals to 1.95. If this minus 0.15, the answer is 1.85. The answer is 1.85. There is no options. There is no options. But if this is not twice, just equal to full load value, option 2 is correct. If it is equals to twice the full load value, then if it is approximate answer, option C is the correct answer. If it is approximate answer, option C is the correct answer. 1.85 is the correct answer. Right? Right? Next one. Next one. Which of the following statement is true in case of dynamic braking separately excited DC motor? In dynamic braking, generally armature disconnected from the supply and connected to a braking resistance. That's it. Armature disconnected from the supply and connected to the resistance That's it. Right? Right? Okay. Next one. Next one. This is a very silly question. This is a DC shunt motor. Even the voltage increased or voltage decreased, there is no change in speed. There is no change in speed because the speed directly proportional to EB by 5. When voltage decreased, then EB decreases and the flux decreases. In both the decreases, the speed is constant. There is no change in speed. There is no change in speed. That's why 1200 RPM is the correct answer. 1200 RPM is the correct answer. This is very, very important question, sir. Since to many days, in every question paper, they are asking one question like this from DC shunt motor. From DC shunt motor. Next one. Next one, fourth one. See this fourth one. Consider the following statements about the armature MMF. About the armature MMF in DC machine. DC machine lo armature MMF is the triangle waveform. This is minimum at D axis, maximum at Q axis. Maximum at Q axis. Sinusoidal is the wrong answer. This is a triangle, correct answer. The MMF waveform rotates with respect to armature is the correct answer. With respect to stator, actually the wrong answer. So which is correct, sir? 2 and 3. 2 and 3 nothing but A, this is B, this is C, this is D. So B and C. B and C is the correct answer. B and C is the correct answer. B and C is the correct answer. Next, which is correct answer in this? The magnetic circuit in a DC machine operating under saturated condition. Actually, saturated condition nothing but the flux is constant here. The armature reaction results in. Actually, this is also analytical question. This is also analytical question. Of course, in the saturated condition, the flux is constant. Increase or decrease depending on the motor or generator is the wrong answer. No change in flux value. Increase in flux value, decrease in flux value in the armature reaction. In the armature reaction, generally armature reaction may be magnetizing or demagnetizing. Here we need to take practically the effect of demagnetization is more than the magnetization. Effect of demagnetization is more than the magnetization. That's why demagnetizing we need to consider Demagnetizing we need to consider decrease the value of flux per pole. Decrease the value of flux per pole. Decrease the value of flux per pole. This is the correct answer. Okay. Okay, this is the fifth one. Next, this is very easy question. Actually, this is not BTech level question. Very silly question. Very silly question. Armature control always low speed less than the rated value. Field current above the rated value. Use of field diverter generally used in series motor speed control. In flux control method, when the rheostat used, the efficiency is equals to N2 by N1. When the second speed reducing, the efficiency also reducing. That is poor efficiency. This is correct answer 2341. 2341. 2341 is the correct option. 2341 is the correct option. 2341 is the correct option. See, third one is the correct answer, ma'am. Third one is the correct answer. Armature control below rated speed. Flux control above rated speed. That's very simple question. Next, seventh one. This is from actually seventh and eighth from power electronics drives. Power electronics drives. If you calculated, this is from step down and this is from step up chopper. This is very easy. This is very easy. The output voltage is 100. Output voltage is 100 is equals to output voltage is equals to input by 1 minus D. 1 minus D is equals to 0.6. 0.6. D is equals to 1 minus 0.6 is equals to D. 0.4. This is very easy answer. This is also as it is. We need to go for back EMF. First we need to calculate the back EMF. First we need to calculate the back EMF. Then after we need to calculate the second back EMF based on the speed. Second back EMF based on the speed. Then after what is the input, what is the output. Simply the V output is equals to V input by D. V input by D. What is that? V input into D. D into V input whatever. Like that we can calculate. If you calculate this, you will get the option A. This is power electronics drives question, of course. Power electronics drives question. Next, ninth question. This is also easy question. DC voltage they given across a bulb. Current they given. What is the power? What is the power? P is equals to voltage into current. 54.6 into 3.76. 54.6 into 3.76. 54 threes are 150 change, and this value around 200. There is no confusion at all. There is no confusion at all. Easy question. Next, 11th one. Which of the following armature voltage control is employed when the supply is DC? When the supply is DC, the DC voltage can be controlled by chopper control. By chopper control, we can control the DC supply. This is very simple question. This is also from power electronics drives actually. Power electronics drives. Next, DC shunt motor, resistance given, voltage, back EMF given, supply voltage given. We know the back EMF is equals to V minus IARA. From this, IA is equals to V minus EB by RA. Higher potential minus lower potential. Higher potential 230, lower potential 200. That is 30 by 0.15. That is 200 amperes. 3000 by 15. That is 200 amperes. This is simple question. Very simple question. Live disconnect and the. This is very simple question. Right? Next and last question in electrical machines. Last question in electrical machines. ESMA 200 amperes. Very good. Consider the following statement about DC series motor. DC series motor. The developed torque in machine is directly proportional to current. No, the torque directly proportional to current square. The motor is suitable only for loads small starting torque. No, generally this is used for high starting torques. This is used for high starting torque. The machine can run even at single phase supply. That is called single phase AC series motor. Single phase AC series motor, nothing but this is not AC motor. This is a DC motor. This is a DC motor. Okay. For that we can give a single phase AC supply. Of course, few modifications are there. We discussed in the class actually. Okay. So this is the option C is only the correct answer. Option C only the correct answer. This many questions are from our machines, electrical machines. Yeah, Mr. John, sure. Surely we will give you the many questions. I will conduct the live sessions as usually. Today I explained only the electrical machines part. In the next class I will try to discuss power systems. I will try to discuss power system questions, UEE questions and measurements questions in the next class. Then after another faculty will discuss power electronics and networks. Then after another faculty will discuss analog electronics and control systems. Analog electronics and control systems. Analog digital control system. Another faculty will come. Still more 3 sessions will take to complete this complete analysis of the question paper. Then after I will try to conduct like a live sessions for different subjects with different questions. Right? So prepare well guys for next polytechnic lecturers. Polytechnic lecturers exam also similar to this one. The multi-selected questions. The multi-selected questions will be more in that also. Don't expect the single statement questions. Don't expect the single statement questions. Not in this month. Coming months we can expect. Tritesh, coming months we can expect. Especially we can expect the even discoms also in AP, but they are doing right. Sure, John. Sure. Okay. Thank you everyone. Please share this video to your friends who are preparing for further exams, and be careful guys who are sincerely preparing for next government jobs. Like a polytechnic lecturers is there, SSC JEE is there, and many exams are there. Prepare well, don't waste your time. Okay, non-technical also important for polytechnic lecturers and SSC JEE. Go through the non-technical question papers also. Right? Thank you Josna, thank you Tritesh, thank you John, thank you Balraj, thank you everyone, thank you guys, Chintu, thank you everyone. TSNPDCL junior linemen will be take some time. Junior linemen will be take some time sir. First SPDCL తర్వాత NPDCL వస్తుంది. ఇప్పుడు తెలంగాణలో డిస్కమ్స్ నోటిఫికేషన్ అయితే ఉండదు. ఏది అసిస్టెంట్ ఇంజనీర్ జెన్కో ట్రాన్స్కో ఉండొచ్చు. మొన్నటి వరకు ఇంకా 1 month లోనే వస్తుంది అన్నట్లుగా చేశారు. బట్ ఇప్పుడు కొంచెం కామ్ డౌన్ అయ్యారు కాబట్టి ఇట్ విల్ టేక్ సమ్ టైం. ఇప్పుడు మన ముందుంది ఒకటే పాలిటెక్నిక్ లెక్చరర్స్. ప్రిపేర్ వెల్ ఫర్ దట్. థ్యాంక్ యూ పరమేష్. Thank you very much. Thank you to all. Bye bye to all guys.